Okay, we're solving equations by collecting like terms. This is something we did last chapter, collecting like terms. So, we have our first example here. What I'm going to do is I'm actually going to define what my like terms are to start. This 3x, are there any like terms in this entire equation? That's right, 2x. So I'm going to highlight the both of them. You can do whatever you like to find them. And what about our constant 2? Yeah, 2 and -4 are both like terms. So what we're going to do is remember the middle of the equation here. It's essentially our equal sign. I'm going to put all like terms, because there's only 2 sets, on one side. I'll put all of our variable like terms, let's say, on the left. And it doesn't matter. It can be left or right. I'm going to put all of our constants to the right. And we'll do this one step at a time. So because I want my variables on the left, I'm going to leave what's already there. I need to move my 2x. Okay? So see if you guys remember the shortcut. If I need to move 2x over, what does that mean? What do I have to do, Chad?
Square it. You have to multiply that.
Subtract. Because this is technically positive 2x, we're not trying to separate it from the x. We're moving the entire thing over. Okay? If we were separating it from the x, you're right, we would divide by 2. But because I want to move 2x to the other side, okay, we need to subtract by 2x. And we'll subtract by 2x on both sides. Okay? Actually, I'll do that on the next slide. So, we get 3x plus 2 minus 2x is equal to 2x minus 4 minus 2x. So I want you guys to get used to this idea here. Even though they're not beside each other, this positive 2x and this negative 2x, what happens? What do they become? 0. So the idea is a lot of times they call it canceling out. It's known as really creating a 0. So I'm just left with -4 on this side. Okay? I'm going to rearrange this. Actually, I'm not. I lied. I'm going to move my 2 over to the other side in the next step. In order to move positive 2 to the other side, what do we have to do? Yeah, subtract by 2, right? It's almost the exact same as before. So 3x plus 2 minus 2x minus 2.
What?
Minus 2. What? What am I doing? Look, they're not beside each other, but it doesn't mean they can't be combined.
Wait, what do you mean?
Okay? I'm moving this 2x to the other side. I'm trying to have only like terms on the left and constants on the left, on the right. So what does this positive and this negative 2 become? 0, that's right. They cancel each other out. So what am I left with on the left here? 3x minus 2x is equal to -4. Oh, yeah, good. Minus 2. Great, you guys are awesome. So, we've just accomplished this. Now, remember, as a shortcut, we'll go through the next question in the shortcut. This one, we kind of used the balancing method. Whatever we did to one side, we did to the other. Very similar to yesterday. So now I have all like terms on the left and like terms on the right. If I were to combine these two like terms, what do they become? What is 3 minus 2?
1x.
1x, right? Or just x in this case. We don't have to write that 1. What is -4 minus 2? -6. So in this case, our x is equal to the value of 6. If I wanted to check it, I would replace the 2 x's in this equation with -6. And then we should have 2 sides that equal. And I don't have room right now to check it. I'm going to try to do this mental math. I hope you guys can follow. Okay? What is 3 times -6?
18.
-18. What's -18 plus 2?
Positive 16.
-16. Okay, so the left side is -16. We got that. Let's try the right side. What's 2 times -6? -12. What's -12 minus 4? -16. So both sides are equal to -16. So we know that this is correct. This is -6. Okay, so let's go to the next example a little quicker here. This time I'm just going to be moving equations to the other side. So let's talk about our like terms. Our like terms are -2k and -5k. And our other like terms are +7 and +8. This time I'm going to move all our variables to the right. Just so you guys can see, it can be done both ways. But instead of balancing, I'm just going to move. So if I need to move -2k to the other side, what does it need to become? Positive, that's right. So on the left, I'll only have the number 7 left. Is equal to, remember that equal sign is very important, 8 minus 5k plus 2k. Right? We moved negative 2k to the other side, so it became positive. Okay? The next thing we need to do, go to the end, is we need to move our positive 8 to the other side of the equation. Now, because it's positive, when we move it, what will it become? Negative. So I have 7 subtract 8 is equal to negative 5k plus 2k. Now we have all of our like terms on both sides of the equation. So what is negative 5k plus 2k? Negative 3k. Excellent. And what's 7 minus 8? Negative 1. Are we done? Have we isolated for k in this case? No. So in the one above, yes, from the basic. In the one above, it was really easy because we didn't have to do this extra step here. It was already x. But in this case, I need to focus on just getting k. So I still have to do one extra step here. How do I separate this negative 3 and this k? That's right. Because it's negative 3 times k, we need to divide. So in other words, to move it over, or I'll do this one in the balance method, and we'll do a shortcut again. We need to divide both sides by negative 3. What is negative 3 divided by negative 3? 1, or 1k in this case, right? And in this case here, what's negative 1 divided by negative 3?
Negative 33.
Negative 0.333. It's not negative, actually. What's a negative divided by negative? It's positive. So it's positive a third. You can leave that as a fraction. I'm fine with that, okay? Last one here. I'm going to do all shortcuts for this one. I'm going to go a little quicker again. My like terms are?
3. Negative 3.
Negative 3 and?
2m.
Negative 2m, great. And what are the other ones?
5 and negative 2.
Great. I want to put the variables on the left. So what do I got to move to the left? Negative 3m is already on my left of the negative 2m. When I move it over, what does it become? Positive. Good. So we get 5 minus 3m plus 2m is equal to negative 2. The 2m has been moved. What's my next step? Move the 5 to the right. What does it become? It's negative. It's already positive on the side. So I'm left with, on this side, negative 3m plus 2m is equal to negative 2 minus 5. I have all my like terms. What does this equate to? Negative 1m. Okay? Or just negative m. And what is negative 2 and negative 5?
Positive.
No, negative 7.
Negative 7. Good. I'm not technically done.
What?
I need to solve for just m. Okay? So what does that mean I need to do? This is technically times what number? Yeah? So in order to get rid of that negative 1, what do I got to do? That's right. So when it comes over, we got to use division. So we get m is equal to negative 7 divided by, it still stays negative. The absolute value didn't change. It was just the operation, multiplication. So m is equal to what number? Negative 7. Positive 7. Negative divided by negative is